All right, so this lesson is on similarity. It's something that most of you guys are already pretty familiar with. So specifically, we're looking at similar polygons. Just to kind of give you an introduction to the idea of what similar figures are, and you already kind of know. Let's say that I were to take a picture of someone. All right, so here's somebody, they're all happy. Okay. They don't have an abdomen. It's okay. All right, we've taken a picture of them. Right? Okay. But this is, let's say, a 3x5 picture. And yes, it would, if I was being realistic. 3x5, thank you. All right. Let's say that I want one that I can put in my wallet. All right? So this is my son, let's say.
Should we draw this?
No, just watch. This is my son, and I want a picture that I can put in my wallet. All right, so I shrink it down, and I make it a 1x1. What is going to happen to my son? I'm not cutting the picture, I'm shrinking it and stuff. Is he going to get fat, or is he going to get skinny? He's going to get pretty darn stumpy, because what I've done is I've taken that 5 and I've smushed it, I've like shrunk this side, so this stuff right here is staying, let's say it's shrinking to 1, but I have to shrink the 5 a lot more. So now he's looking more like this. Yeah? That's not good. I would like my child to look proportionate. So what should I have done? Let's say that I wanted to keep that top side a 1. What would this other side have to be in order to keep these things in proportions to each other? How did I go from 3 to 1? Divided by 3. So I would have to take 5 and it would have to be 5/3, wouldn't it? 5/3 of an inch. Okay? So you guys already are pretty aware of what it means to be proportionate. You want your figures to expand and shrink in proportion to each other. All right? So let's take a look at an example. I'm going to start with number 7. All right, you've got a bunch up there that are just two fractions set equal to each other that you need to solve. That's because what you're going to do once we get to the shapes is set two fractions equal to each other. You guys are going to have to come up with the fractions, but you'll come up with two fractions that are equal to each other and you'll have to solve it. So let's take a look at 7 together. Can somebody help me out? What is number 7? Whoa, okay. Can I hear it from Aaron? All right. Whenever you have two fractions equal to each other like this, you can solve it with cross multiplication, which I believe you guys have already heard of in the past. Yeah? So when you cross multiply over an equal sign, and it must be over an equal sign, you take the numerator times the denominator over the equal sign. So in this case, I would have 7 times x minus 9. Notice that I did put parentheses around x minus 9 because the 7 needs to multiply to the entire thing, not just one part of it, right? So what would my other side of this look like when I do this part of the cross? 3 times x plus 5. What did I do wrong here? I didn't put the parentheses, so as of now, the 5 isn't getting multiplied by 3. You guys see that? That's going to be bad. So I do need to group it and then distribute. So here I will distribute, and get 7x minus 63 equals, distribute, 3x plus 15. Okay, I am going to subtract my 3x from the 7x to get 4x, and I'm also going to add my 63 to my 15 to get 78. I'll ask you guys for fractions on this. So when you divide by 4, you just need to simplify the fraction. Does 78 divide evenly by 4? Not quite, but does it divide evenly by 2? So you guys, what's 78 divided by 2? Very good, 39. 4 divided by 2. And that's as far as I can go. Are there any questions on how to solve these proportions when you have one fraction equal to another? Okay, so let's move on in the worksheet and do another example. I'm going to kind of skip around, so bear with me. Okay, so if we're looking at number 15, the directions say that the polygon in each pair are similar, and we need to find the missing side length, right? Okay, instead of using a question mark, what do you think might be easier to use? An X, yep. So I'm going to, instead of using that, I'm going to put an X over the top and use an X instead. Okay, so just like what we did with the picture at the beginning of this, that photo of the little stick figure, okay? You know that these things should be in proportionate sides to each other, right? So what you can do is say 20 is to 24. So 20 compares to 24, right? So I could write a fraction, 20 is to 24, as, careful, and I'm glad actually that you said that. So he just said 20 is to 24 as 36 is to x. Why is that not good? It should be x to 36, right? If I go from small figure to big figure, I need to keep that pattern and go from my small figure to my big figure again. Does that make sense? So that would be equals x over 36. If we solve this, we're going to get cross multiply 24x equals 720. Multiplying 20 times 36. What is 720 divided by 74? Or 24, sorry. $30. Very good. So x is going to equal 30. I want to point something out. There are usually more than one ways that you can set up these fractions. So let me try another one. Let's say rather than comparing 20 to 24, I had done 20 is to x. So 20 is to x. What could I set that fraction equal to? Keeping the pattern. 20 is to x as 24 is to 36. Does everyone see that? You'll notice here that when I multiply, I still get 24x equals, and I still get 720, right? And now it's the same exact problem. So usually there's more than one way that you can set up your problems. The main thing that you have to watch out for is pick a pattern and stick to it. So in other words, if you're going to move for one fraction from one figure to the next, then you need to pick a figure to have on top and pick a figure to have on bottom of your fraction, right? If you're going to stay within one figure for a fraction, then you need to say like a short over a long, and then keep that pattern and do a short over a long on the other one. You pick a pattern and you stick to it. Are there any questions on that? Okay. Number 19 is one that you can also use for numbers 11 through 14 on the front. They'll be very, very similar to this, all right? So keep that in mind that number 11 through 14, 19 through 22 are all similar to each other. I'll do this one to help you guys out. The only difference on this than from the last picture is that rather than having two separate figures drawn next to each other, they're embedded in each other. Do you guys see that? So in other words, when I'm looking at this, I have a big triangle and I have a little triangle. It's just that rather than having the little triangle separated out to the side, it's inside of the figure. Do you see that? You're still looking for similar parts and looking for a pattern. So in other words, I'm going to go ahead and put an X on my missing side. I'm going to say rather than a question mark, let's find X. So I'm always going to start by picking something to compare x to. So in other words, if I'm looking up here, I could compare x to what? I'm hearing 6 and 16. Could I use either? As long as I use a pattern. So we'll do both setups and show you how you can use either one. So let's start with, let's say I wanted to do x is to 16. Let's see how that's going to look. All right, so if I write x over 16, I need to find the pattern. So notice that my pattern here was to stick on one side at a time, and I chose the top part to the bottom part of the triangle, right? So on my other side, I have to do the same thing. I'd have to do my top part to the bottom part. Do you guys see that? So what is the top part of the other side? 6. Do I have the bottom part of this side? A lot of you are going to be tempted to say that this is 6 over 18, but that would be the top part to the whole. Is that what I did on the other side? Right, so you'd have to actually find that, which is 12. You'd have to put that in yourself. Sometimes you guys are going to have to do that, where you like put in an extra piece to help you do that. You do your pattern. Again, do not stray from your pattern. If you're going to do top chunk to bottom chunk, it must be top chunk to bottom chunk over here too. See what I'm saying? Okay, so for that, I would say is equal to 6 over 18. Now I can start doing my solving. So I'd have 18x. Oh, I'm sorry. Did I write? I meant 12. You could do that once I have it written. So Aaron was just asking, couldn't I reduce my 6 over 12 to 1/2 so I don't have such big numbers? Absolutely. So you could take a step to say, well, that's 1/2, and now you have smaller numbers to deal with. And in fact, in this case, you don't even have to cross multiply because it's pretty easy just to get x by itself here, right? Cross multiplying will always get you there, but can you guys see what I would have to do here just to get x by itself? Rather than cross multiply, I could multiply by 16. So don't get caught up in like, one set way. It's just that cross multiplying is going to help for the more complicated ones. But things like this, you guys should be able to kind of just find the most efficient method. Let me do another setup so you guys can compare the two. So let's say that I had done x was to 6 instead. So if I did x is to 6, what would be my other setup? 16 to 12. Yep, so if I did a section and a section, then I would have to do 16 is to 12. Let me show you one more so you guys could go through and solve that, right? A last option that you could do, and it's definitely not the most efficient, but I want to see if you guys can come up with it. What if I had started with doing 6 is to x. So let's say I did 6 was to x, and then instead of using the 12 that I had an extra put in there, I wanted to use the 18. So I did this side, 6 was to this side x, right? And now I'm looking at this side 18. What would I have to put from this side to get the whole? 16, not minus, but plus x to get the whole. Do you guys see that? You can do things like that as well. It's just that this one is going to have kind of an uglier cross multiplication. Okay? But do you guys see what I mean by there's a bunch of different ways you can do it? Find your pattern and stick to your pattern. All right, so for this last set of problems, you're being asked to state if the triangles in each pair are similar, and if so, give the congruent statement for them. So what were the two things that I mentioned when I said two figures are similar? What do you know about them? They have, what's true about the angles of similar figures? They should all be the same.
Which one are we doing?
Look up at the board.
There's 3 columns.
We're doing 23 and 24 so that I can show you both types.
Oh, got it.
Okay. What I'm trying to talk you through is what are you looking for when I ask you if two figures are similar. If you are given enough information to start looking at angles, you would just need to show me that all of the angles are the same in pairs. If I don't give you any information about angles, but instead I'm giving you information about sides, what do you know about sides of similar figures? They should be in proportion. So you would, rather than finding a missing side, so you'll notice that here we're not being asked to find a missing side. But you'll still use proportions to see if the fractions are the same. You want the fractions to be the same, right? That's the whole point. So we'll still use fractions, it's just that we're not solving for x. We're using the fractions to see, are these actually the same? So let's do the first one. I'm just going to talk you through it. For the first one, do you have any side links? That's a big hint to you that you should be looking at the angles and showing me that the angles are the same, right? Notice that you have a small triangle embedded in a big triangle. So angle J on the small triangle is which angle on the big triangle? J, right? This angle on the small one matches the angle on the big one. Are they the same measure? Duh, it's the same angle, right? So of course they have to be the same measure. So there's one angle that matches. How can I show that, so which angle would match up with angle C in the small triangle, which one would match it in the big triangle? Which one? K. How come these angles are the same? How can I mark those? What markings are you given here? What kind of angles are these? Corresponding angles. Are corresponding angles congruent when you have parallel lines? Yes. Can I do the same thing with L and D? Absolutely. So are these triangles similar? Yeah, but only because I could show that all of the angle pairs match each other, right? When you say your similarity statement, so if you have decided that the two triangles are similar, make sure that you put the order of the letters in the right order. So in other words, if I put JKL, that's JKL, what order should I put the small triangle? JCD. That will matter. You do need to put them in the correct order, like we learned in semester 1. That's it. For number 24, do I give you any information that would lead you to anything with the angles? Parallel lines? No, I haven't given you enough information for angles, right? But I have given you side lengths. Couldn't you check those side lengths to see if they're in the same proportion to each other? So set up the same exact type of thing that we were doing on the other problems, except for you won't have a variable. So in other words, let's say I start with 24, I think it is. Is that what it is? Or 20? 20. Sorry, yeah, it's 20. What could I compare 20 to? 20 is to what? 35 would work. What else could I compare it to? 33. So you could either compare it to the other side in that triangle, or you could compare it to the matching, like the same side it would be in the other triangle. Does that make sense? Equals, so notice that my pattern here was to do short side to short side in different triangles. So what should my other fraction be? Long side to long side in my triangles in the same order though, right? So I'd have to do 33 is to 56. Do I know that these fractions are the same right now? I'm questioning this. This is the whole point of this problem is now you don't have an unknown, you have numbers. Are they the same fractions? So somebody type in their calculator for me, what is 20 divided by 35? To the nearest hundredth, let's say. What was that? 0.571. Somebody type in 33 divided by 56. 0.59. Yes. Okay. Are these things equal? So are these similar? Yes or no? No, because they don't have the same proportion. So this means not similar. And so if I don't have a similarity, would I fill in that similarity statement? No, you would not. All right, so think about which methods you need to use. 25 and 26 look a little bit different, but they're going to use really similar techniques there. So I've given you enough to be able to get through this worksheet. You can either finish this worksheet in class today or do the textbook homework from 6.7. Both of them are due on Tuesday next week. Okay?